Hi guys, my name is Terry. In this video, I'm going to go through with you Additional Mathematics Form 5 textbook question for Chapter 1 Circular Measure Formative Exercise 1.2. If you enjoyed this video, kindly like, subscribe or leave us a comment if you have any question. So let's get started. Now for the first question, you're given a diagram that shows a circle with center O. The minor arc length RS is 15 cm and the angle of the major sector RS is 275. So you're supposed to find angle subtended by the minor sector RS. Now remember, major means the big angle, minor means the small angle. So the first part is we need to find out the minor angle of ROS. So you can write here minor. It will be 360 minus 275. That gives us 85 degrees. Now this 85 is in degrees. We need to find the angle in radian. So I need to multiply with pi, divide by 180. Now, just so you know, in the textbook, we use pi as 3.142. So remember that everything use 3.142. Type in your calculator, you should get 1.484 radian. Okay, second part, find the radius of the circle. Now we know the length of arc is 15, so we can use this simple formula S equals to r theta, where the length of arc is 15, the radius is an unknown, I'm going to call it r, and this angle here 1.484, yeah, is the angle for minor angle RS. So this is 1.484. Again, use your calculator, take 15 divided by 1.484, your radius is 10.11 cm. Okay, that is question number 1. Moving on to question number 2. So diagram shows sector UOV with the center O. Now the arc length UV is 5 cm and perimeter of the sector is 18. Find the value of theta. Now if you are given the perimeter, well, we do not know the radius. So we can actually assign the symbol R to represent the radius. Since I know the perimeter is 18, we can add them up. R plus R is 2R plus 5. The result is 18. So 2R equals to 18 minus 5, which is 13. 13 divided by 2, 6.5 cm. So you need to find the radius first. Once you know the radius and we know the length of arc is 5, we can use S equals to r theta. The length of arc S is 5, radius is 6.5. To find theta in radian, yeah, remember when you use the formula S equals r theta, theta is always in radian. Take 5 divided by 6.5. Use your calculator, you will get 0.7692 radian. Okay, simple. That is question number 2. Moving on to question number 3. Diagram on the right shows sector EOF of a circle with center O. Given that OG is 4 cm, OE is 5 cm, find the value of theta in radian. Okay, number 1, if I know the length, I know the length of these two sides. To find angle given length of two sides, we need to use trigonometry. Since this is a right angle triangle, you can see that I can use SOHCAHTOA. Now to decide what to use, we have to look at which is your opposite. This is your opposite. OG is your adjacent, OE is your hypotenuse. If you're given adjacent and hypotenuse, we can use cos. Let's write this as cos theta equals to 4 over 5. Now to find theta, you can use your calculator. We call this an arc cos or cos inverse. Please press shift and then press cos button in your calculator. Right, and be sure to change your calculator to radian mode, depending on which model you're using. So I hope you know how to change your calculator to radian mode so that whatever you're getting here is straight away in radian. Now I don't recommend using degree mode, because if you use degree mode, you will have to convert from degree to radian, and when you convert from degree to radian, you will have to use 3.142, which is very, very inaccurate, right? So you just change your calculator to radian mode, shift cos 4 over 5, you will get 0.6435 radian, right? Okay, so that is angle theta in radian. So to find perimeter, The next thing I need to do is I need to find the length of the three sides that we're finding here. So number one, we know that if this is 4, this is 5, we can use Pythagoras theorem to find EG. And it's fairly simple, right? We already know 3, 4, 5, the ratio. If you're not sure, you can just use your calculator, take 5 square minus 4 square, square root. This will give us 3. EG is 3 cm. And if EG is 3, OG is 4, we know that the radius of a circle is always the same, which is 5. So we can find GF. GF will be 5 minus 4, the difference is 1 cm. So this part is 1 cm. I just had to add the length of arc EF. Okay, I'm going to write here separately. Length of arc EF equals to r theta. My r is 5. Theta is 0.6435. I got 3.218 cm. So last part is to add them up together. First, we take, maybe I start with 3. I plus with 1. I plus with 3.218. My perimeter is 7.218 cm. Okay. All right. Move on to question number 4. Now here the diagram shows two sectors, OPQ and ORS. With center O, the radius is 2h and 3h respectively. So angle POQ is 0.5 radian. Perimeter of the shaded region is 18. So find the value of h. Okay, number one, if you're given perimeter, we know we need to just to find length of all these sides. So we know this will be h because 3h minus 1, 2h is 1h. These two sides are h each. PQ and RS we can find. Yeah, so I think I'm going to do one shot. Okay, so PQ, length of arc PQ is now r theta. Your r or radius is 2h. Your theta is 0.5. Then length of arc RS, it has a radius of 3h here, multiply with theta 0.5, right? And then you plus the length of PR and QS here, they are both h, so I plus 2h, and the result must give us 18. Okay, so actually this one you can use a calculator, or I'll show you one by one. 2h times 0.5 is just 1h, 3h times 0.5 is 1.5h, sorry, this is a plus sign. So you plus with another 2h, you get 18. Add them up, 4.5h is 18, h is 18 divided by 4.5, h is just 4. Alright, that is part A. So for part B, you're finding the difference between the length of the two arcs. Okay, the two arcs are RS and PQ. So we say the difference will be length of RS minus length of PQ. You don't have to write all this out, we can calculate straight away. Now the radius RS is 3h. 3h means 3 times 4, right? Since h is 4, you multiply with the radius, with the angle in radians 0.5. For PQ, the length of arc PQ here has radius of 2h, which is 2 times 4. You multiply with the angle 0.5. So this is, okay, you can count 12, 0.5 is 6, minus 4, the result is 2 cm. Alright, that is question number 4. Moving on to question number 5. So diagram on the right shows part of a circle with center O, radius of 10 cm. So tangent to a circle, point M and N meets at point P. Now when they say a line is a tangent to a circle, we know in Form 3 you learn that when a line is a tangent to a circle, the line must be perpendicular to the center. Yeah, the line must be perpendicular to the center, like this. So this is 90 degree, this is also 90 degree. So the first part, you're finding the length of MN. MN is an arc of a circle, so we can just say S equals to r theta, your radius is 10, theta is 51, please convert to radian by multiplying with pi over 100 here, 51 is in degree, and please use 3.142. So my answer is 8.902 cm. Okay, to find the perimeter, we need to find the length of MP and length of PN. But they are both equal actually, because we can divide this evenly at the center, right? And remember, this is Form 3 stuff. You learned this in Form 3. So let's say, for example, these two are both tangent to the circle. We can divide evenly at the center, and these two will be equal length, right? Or these two will be equal length. The angle here will be the same. This angle, two angle here will be equal as well. So let's just focus on this MP. We know this is 10 cm. We know this is O. Now, when you take 51, you split in the middle. The bisector, angular bisector here is 25.5. So let's find out the length of MP by using tangent. So we know this is your opposite, this is your adjacent. To find your opposite, we use tangent 25.5 in degrees, MP divided by 10. Please remember, when you use sine, cos, tangent, the unit that you use in your calculator, the mode that you use is very important, because if your calculator is in radian mode, they will give you 25.5 radian, which is a different value, right, compared to 25.5 degrees. So make sure your calculator is now switched back to degree mode. So use your calculator, multiply over. My MP is 4.770. Okay, to find your perimeter, you need to add them up. The length of MP and PN, they are actually the same. So I can take 4.770 times 2 plus the length of arc MN here, which we got from part A, 8.902. My answer is 18.44 cm. Okay, that is question number 5. Okay, moving on to question number 6. A wall clock has a pendulum with length of 36 cm. It swings through an angle of 21. So we draw, say the clock has a pendulum like this, right? The angle here is 21. So find the total distance covered by the pendulum in one complete oscillation. So one complete oscillation means I move here and I come back, right? So that means the length of arc here is twice. Yeah, the distance traveled is 2 times the length of arc. So we know distance traveled is 2 times length of arc, S equals r theta. The length of the pendulum is 36 cm. So you have to multiply 21, but this is in degree. You have to convert to radian. Yeah? Remember, this is actually S equals r theta. Yeah, the radius is 36, theta is 21. You multiply with pi over 180, but make sure you times 2 and use 3.142 for your pi. I got 26.39 cm. Okay, lastly, question number 7. Diagram on the right shows measurement of a car tire. So what is the distance traveled if it makes 50 complete oscillation? Okay, now it's not a difficult question. Actually, we can look at the radius. The diameter of the tire, right? The diameter is just, let me write down, diameter is 14 plus 36 plus 14, which gives us 66, right? Now, if you want to find radius, it will be 66 divided by 2, which is 33 cm. But the question wants to find distance traveled in meters, so I'll just convert this to meter by dividing with 100. Alright, so the first part, what is the distance traveled if we make 50 complete oscillation? So one oscillation is 2 pi r, right? In fact, I don't call this end maths. I think this is like the normal maths, right? Yeah, Form 2 maths, okay? So the distance traveled will be 50 times of 2 pi r, 0.33. Use your calculator. Please use 3.142 again for your pi. You should get 103.686. But actually, you don't need so many decimal points. But a textbook gives this answer. All right. If you want to round, you can. For normally in exam, 4 SF will do. But like I say, textbook gives up to 6. So it's okay. Whichever answer you want to leave it is up to you. Okay. Next one. This is for 50 complete oscillation. If I want to do 1,000, so I don't want to recalculate this. For 1,000 oscillation, by the way, this one is diameter, this is distance, just to be sure. There are 2 different D. So the first one, the distance is for 50 oscillation. The second one is for 1,000. So your distance travel will be, let's take, for me, I don't want to recalculate, so I take this result, 103,606 in meter. This is for 50, I divide by 50, I multiply with 1,000, just use ratio. Okay, you should get 2073.72 in meter. But again, this is like 6 significant figure. You don't need such high accuracy. So if you use 4 SF, it will be 2074 in meter. But again, like I say, textbook answer, they gave this answer. All right. So that's all. If you enjoyed this video, please like, subscribe, and we have more books, exercises that if you think you will be interested to get, we have from our Shopee account. You can contact us or find us on Shopee. Thank you very much for watching.